Short video on DC to DC converters, specifically these little Chinese ones that seem to work okay, but this one has an input voltage range of 3 to 20 volts, and it tops out on a boost up to 40 volts DC. But what's interesting about these, when you first get them, connect them up, you may find that they don't appear to work. And in some cases, they get really hot. The little boost I see there, it's really toasty. So let me set this up for you, and hopefully you'll get some benefit from this, as I did. What I have is this is an aircraft instrument, and what I like to do, kind of a hobby, is to gut them and turn them into clocks, desk clocks. So kind of cool that I think I picked this box up for like $35, and it's a FM communications control box, and I've got all the associated hardware, thumb switches, everything else that I'm going to put a clock into with this display that uses a MAX 7219 and then a little network time protocol ESP32. So where I am with this is all of that stuff runs on 5 volts. Everything runs on 5 volts. But guess what? I need 28 volts to run the incandescent lights inside of this Lexan panel. So what I've got to do is boost 5 volts to 28 volts. So simple enough. So when you connect your DC to DC converter up, it won't start. And I'll show you what the problem is. Now you'll notice I'm feeding this DC to DC converter 12 volts in, and it's consuming about a half an amp. And I'm getting 27.01 volts out. Over here on my power supply, this display up here is just a digital version of what's going on down here. But what I want you to watch is if I start to limit, here's a good way to do it. Let me explain what I'm doing. So if I turn everything off, so that guy's off, everything's off. Now I want you to watch the inrush on that DC to DC converter when I turn this on. So the meter on the right is inrush. You see I jumped up to almost 4 amps, but then I leveled off at a half an amp, and that's the running current for this. So if I constrain this current, and I'm getting 27 volts out, if I constrain this current and turn this current down, and I limit this inrush, if you limit the inrush, okay, now, and it's some arbitrary value, but I'm sure that's pretty low. So I limit the inrush. Let me turn it off. Okay, I'm going to turn it on, and you'll notice I've got the current switchover light, which means I'm constant current now. But notice that now I'm drawing, now that I'm in constant current mode, I'm drawing 2.28 amps, and it's dragging the voltage down from 12 volts down to 3.65. And you'll notice instead of getting 27 here, I'm getting 18. Well, the problem gets worse the more you limit this current. So if you want to drive one of these DC to DC converters, you have to have enough headroom on your power supply for that inrush. If you don't, the converter can't start. And in some cases, this particular one yesterday just oscillated back and forth. I mean, the voltage was all over the place, the current was all over the place, and it never started. And I was never able to get more than like, maybe 8-10 volts out of it. So the moral of the story here is to make sure that you have enough current to start these DC to DC converters, especially the ones that I think this one will drive, I think, a 3 amp load, but I don't believe it. It needs to be heat sinked for that, because this little guy, he's kind of toasty, so we'll not do that. So I'm gonna turn this off. What I'm gonna do is I'm gonna open up the current again, okay, and then notice the inrush. Well, see, I'm still current limited, I think. So I'm going to turn it off again and give it a little bit more. Okay, now we'll see my inrush on start. Okay, so it's better. Let's see. Yeah, it's interesting. I think when you get kind of marginal on the amount of current you give it, if you limit, then it doesn't seem to. Let's see. Okay, so I'm still getting a little bit of a bump here, and we're back up to 27 volts and roughly 12 volts in. But you notice our current dropped from 2-3 amps when it was current limited, or constant current, dropped to now it's a half an amp. So the point is, if you've got like let's say you've got a 1 amp power supply and you want to drive this DC to DC converter, and these are very common, it's not going to start because that power supply can't deliver that inrush kick to get this thing going. So that's the key, is with these DC to DC converters, you really need enough headroom on your power supply. Even though the resting, this thing loaded is just a half an amp at 27 volts, you need enough headroom for that converter to start, even though the resulting current you're going to draw is not that much. So, hey, I hope this helped, because this one was really a head scratcher. And oh, by the way, just as an interesting point, these are incandescents in here that power this, so that light this dial up. And what I thought was the original issue was these are I think there's probably 12 to 15 incandescent bulbs in this panel that backlight this. And what I thought was giving this DC to DC converter trouble was that all those incandescent lamps in series look like a giant inductor. So what I did do is I put a back EMF freewheeling diode in there, which I think helps a little bit, but the real issue is I just didn't have enough headroom. This is a 15 volt, 6 amp power supply. This Tektronix power supply that only supplies 1.5 amps at 12 volt, when I set it to 12 volts, would not start this converter. So if that gives you any idea, even at 1.5 amps, it goes into constant current mode, and it curtails the voltage really low. So it wasn't until I put it on this 6 amp supply that gave it enough headroom on that inrush to start the converter that it worked. So anyway, hope this helps somebody figure these things out.